following video is a best practice guide for a jointer support on a cabinet reshell. Some sequences in this video have been shortened or speeded up for ease of viewing. During parts of the video, barriers have been opened or removed to facilitate filming. In a live situation, full enclosed guarding must be in place. In this video, we'll look at two main scenarios: strips cross-connection systems, modular cross-connection systems, and then we'll touch on mixed cross-connection systems, which is simply a cabinet which has both types of systems within one shell. The video covers the two work locations seen here. So let's get started. Complete a full risk assessment of the area, cabinet shell and joint box before proceeding. It's essential the civils team fully identify all buried surfaces or other situations which may stop the reshell taking place prior to commencing any work, as you can see here. Once agreed the work can take place, you now need to check there's enough slack in the joint box to facilitate the rehanging of the internal components. This amount can vary with each situation. If there isn't enough slack in the first joint box, check further down the cable route. If there isn't enough slack overall, then the reshell must not proceed, and the planner must be contacted and informed, and neither the civils nor the jointer assist can proceed. It's now essential to remove the duct seals to make sure the slack in the box can be pulled through the ducts. Using the Resin 14 removal toolkit, we start by drilling a series of chain holes with the 5.5mm drill bit supplied. This is done in a clear area of resin as not to damage the cables underneath. We then widen them with a 10mm drill bit to create a slot. We then drill a series of chain holes around the outside of the seal. This is to weaken the bond to the duct. If at any point you suspect asbestos duct is involved and may have been damaged, please refer to the Health and Safety Handbook. There's a link at the end of the video. The hooks can now be inserted, the resin lifted and removed. Constant gas monitoring must always be adhered to as per training. Guidance to duct sealing and repair can be found in the link below. Within it is a more in-depth video. Once the duct seals are removed, we cut away the restraining cable ties and make sure the cables in the duct are able to move freely. Now let's turn our attention to the internal components and see what else needs to be released before the shell can be removed. Here are two transducers on the right hand side of the cabinet. In this scenario, the earth bonding connection is connected at the back of the assembly, but could have been connected at any point in the cabinet shell. Here's the telemetry connection to the D-slam. In this instance, we have a Midland shelf and strips cross connection assemblies mounted to the same back mount frame. We have a further transducer mounted to the left. And a speaker pair buried behind the jumpers. Carefully release the transducers or pressure gauges. Carefully secure them to the existing assemblies. Release the mounting bar from the existing shell and any rails which may inhibit the extraction of the shell using the appropriate tools. Take care not to damage existing jumpers when removing any bars or rails. Re-jumper where required. With the assemblies released and the centre bar removed, the components can be eased forward and protected with a sheet before lifting commences. At this point, the civils gang can safely extract the old cabinet shell. Here you can see the existing shell has been removed and the assemblies are supported using the PCP connection support frame. We can now see why protecting the connections was so critical. With the new shell in place, now pull sufficient cable from the joint box in order to rehang the assemblies. Repeat the process for all cables required. With the assemblies leant forward, identify the upper and lower mounting points. The top and bottom mounting bars should always be adjusted to ensure the assemblies are mounted at the correct height, and all connections must be above the door entry level. Bars can be turned 180 degrees to the up or down position. They can also be drilled. If existing mounting brackets are corroded or further adjustment is required, replacement mounting bar kits can be used. Here you can see the mounting kit being installed and left loose so it can be hung over the mounting bars. Here's the fixing on the top of a strips cross connection. There's also one at the bottom. Both must be securely fixed to the mounting bars. The assemblies can be carefully lifted and hooked back onto the mounting bars, checking they are vertical and spaced correctly before finally tightening up with the appropriate tools. Take care tightening the screws so as not to damage the jumpers or the terminations. Now let's look at the release and rehanging of modular connections. Where modular connection systems only are to be rehung, the mounting bars are removed. The mountings are connected directly to the cabinet using the mounting rails as shown here. A series of predefined holes are available. Holes marked B are for BITS modular mounting systems. Holes marked K are for Krone, Quanti and toolless mounting systems. Where a mixture of modular and strips cross connection systems are to be rehung, the mounting bars are to be used, and appropriate column fixing kits and jacking bolts and brackets must also be used. Again, the mounting bars can be turned 180 degrees. They can be moved to the up or down position. Now we have an understanding of where the different modular systems attach, let's have a look at releasing them. Firstly, identify the location of the mounting rails. Now carefully remove the modules in front of the screws. Now back the screw off approximately 4 turns. It must not be completely removed at this point. Now carefully remove the E-side module to expose the screw beneath. In highly populated cabinets, this can sometimes be tricky due to the volume of jumpers around the module. Take extra care to just release them enough to get to the screw. Again, back off the screw approximately 4 turns. This will allow sufficient movement to lift the assemblies when all screws have been slackened, as shown here. Now identify the lower fixing point and repeat the process. When trying to gain access to the lower screws, it's often necessary to remove 3 modules. This is due to the incoming cables obscuring the screws. When removing multiple modules, it's important that they go back in the same order. If they are not already numbered, you must mark them as you remove them. This is vitally important so that the routing and records in the cabinet match what are recorded on the system. Again, back off the screw approximately 4 turns. This particular model of Quanti module requires no tools. They are simply removed by applying pressure both sides and easing forward. These are numbered across the top. Again, if not, it's vitally important to number them. With all the screws released, the modules must be reinserted into the back mounts before any lifting can commence. At this point, carefully release the transducers or pressure gauges and securely attach them to the modules. With everything now back in place and the transducers secured, lifting and release of the back mounts can now commence. Appropriate PPE must be worn during this procedure, gloves and eye shields. Carefully lift the back mount and ease forward, releasing them from the screw slots. Continue to do this for each column until all the back mounts are free and can be eased forward. They can then be protected with a sheet before lifting of the old cabinet commences. Once the old shell is removed, the verts must be supported. This is done using the PCP connection support frame. It must then be resheeted and re-protected. With the new shell in place, the rehanging can now proceed. The assemblies are reattached in reverse order to detachment. Leaning the assemblies forward, first remove the top and bottom mounting bars. Where mixed connection systems such as stripped cross connection and modular connection systems exist, the mounting bar would be left in place. Identify the correct fixing points. K is for chrome, Quanti and toolless back mounts. B is for BIX back mounts. Place an M4 20mm screw in each location the back mount needs to be attached, in both the top and lower rail. For the B position, this would be a 20mm M6 screw. Leave approximately half the thread protruding. This will enable you to hook the back mount onto the exposed screw. Carefully ease the assemblies back into the cabinet, focusing on lifting one vertical at a time into place. It's best practice to tighten the modules as they are lifted into place. This stops them becoming dislodged as the next column is lifted into place. For Quanti modules which may have become damaged and no longer hold to the back mounts, locking wedges should be used. Toolless module locking wedges will also soon be available. Here you can see we're going to need some of that slack identified at the beginning of this process. Pull up sufficient slack on each of the cables. The top tip is to remove the connections and look through the mounting frames to align the screws. Proceed to reattach each column, tightening down the screws as you go. With all the modules now back in place, we just give it one final check to make sure that all the screws were secured. Before reattaching the pressure gauges or transducers, first you need to select the best left or right position for them to be attached. It may be necessary to move the transducer back mount plate to the more appropriate side of the cabinet. This is very simple and is done by removing the 10mm bolts and nuts and moving the mount in place and reattaching and securing as seen here. With the mounting location selected, we now turn our attention to the pressure equipment. First, we identify and mark the transmission pair. Short air tubes must be extended one at a time to ensure they are correctly attributed to the right cable. Cap off any pressure tubing which requires extending. Fit the approximate length of extra tubing required using the approved fittings. This can be refined when the transducer is in its final mounting position. A link to the ISIS with the approved pressure fittings can be found below. If enough pipework exists to reach the mounting plates, these can simply be refixed using the appropriate length M4 screws. The length will depend on the type of transducer or gauges to be fitted. Here's an extended tube with the correct pressure fittings installed. Now rerun the jumper wire to the pre-identified comms pair if required. Follow this process for 3 or more transducers. Taking one leg from each of the uppermost transducers, crimp these together with a single leg of jumper wire to extend the circuit as shown using the connector wire insulator 8Bs. Now connect the lower transducer to the extended jumper wire and one leg of the comms pair as shown here. Now repeat the process for the other leg of the pair. Secure all wires using straps cable fixing number 1. Then finally, use leak detection fluid on any fittings and joints. Now we turn our attention to the duct seals. Clean and abrade the cables and duct entries as per the Resin 14 installation instructions. For empty or sparsely populated ducts, the supplied foam dam can be used, set between 20 to 30 mm below the top of the duct. Where multiple cables are present and the use of the foam dam isn't practical, dam the ducts with paper towel. Carefully ensure between the cables is also dammed. This will stop the ducts from becoming engulfed with resin. The resin can now be discharged and filled to the top of the ducts. This should ensure you've got 25 to 30 mm depth of cover. Here's a few of the things you can be getting on with whilst the duct resin cures. Reconnect the D-SLAM earth bonding cable to the earthing stud in the left or right bonding position in the PCP using a 13mm spanner. Where equipotential bonding from the D-SLAM or G-Fast unit has been disturbed or reconnected, then both the D-SLAM and PCP earth connections will need to be retested and an electrical installation condition report must be produced. For full information, refer to the ISIS link below. Refit or renew any existing speaker pair. Here you can see us renewing the existing speaker pair within new NTE to show the process. Here you can see the installed NTE with the number marked. Resecure the D-SLAM telemetry block to the bottom mounting rail as shown here. All cabinets must be sprayed with their identification number. This is done by firstly marking out 40mm from the top and side edge. Apply the correct number stencil. Now mask and protect the surrounding area. Spray with white acrylic paint. This process needs to be applied to the top right hand door and both end panels. Now the resin's had time to cure, we restrain all incoming cables, maintaining the bend radius and ensuring no cables are kinked in the process. Using the appropriate tool, cut off all cable ties flush, leaving no sharp edges. Check all cables are now secured. Now re-restrain all cables released at the beginning of this process. Any defective joints which cannot be remedied on the day should have the appropriate 1024 raised. The joint box should look as good, if not better, than when you first entered it at the start of the job. Now check around the whole area for any defects which can't be resolved on the jointer support. Here you can see a broken strip which must be reported via the 1024 process. Raise the appropriate 1024 as required. Here you can see both cabinets finished and ready for future service. This concludes the Insight video. I hope you've enjoyed watching. Here are some essential links to reference materials.